So this is a movie related to scientific notation, and scientific notation is considered to be the standard form or the standard index form of writing a number that is either too big or too small for our writing purposes. So just as an example here, I have two examples here just to deal with a larger number and dealing with a really small number and how we move a number into scientific notation. So we have 17,256, but I mean, this is not even a really big number, so we're going to make this actually 17,256,000, okay? I've just added 3 other zeros onto that. So when we're working in these type of numbers, the first thing that we want to be aware of is, are we moving our decimal place to the left or to the right? Because that will dictate to you if your exponent is either positive or it is negative. So when we're looking at our first example here, okay, that's 17,256,000. What we're going to do is we're going to move the decimal place. It is assumed if there is no decimal place given to you that it does fall at the very end of that number, that last whole number, or decimal place or value, which is 0. So what we're going to do is we're going to move our decimal place to the left. So when we are moving our number into scientific notation and we go to the left, we will have a positive exponent. Okay, so what we're going to do is we're going to count how many times we move that decimal place until there is only one digit to the left of that decimal. So 1, 2, 3, 4, 5, 6, 7. Okay, so the exponent that we have is going to be 7. And now we're going to write all of those digits again, excluding our zeros. So we have 1.726, and then we're going to then move it into our scientific notation by putting times 10, which is our base. It's always our base in scientific notation, to the exponent positive 7. And again, you can check to make sure with your calculator by putting in your final answer and pressing equal. You should actually get that original number back. Okay, so when you're dealing with large numbers and we move the decimal place to the left, that will always mean a positive exponent. And keep in mind that you only want one digit to the left of your decimal place. Okay, so if you said 17.256 times 10 to the 6th, that would not be correct. So if we look at our example down below, we have a really, really small number because we've got all of these zeros in front of the actual true numbers. So because we're moving and this actually does have that decimal point there, which tells us that it is a very small number. So with that decimal place, we're going to move it this time to the right. And so because we're dealing with a small number and we're moving that decimal place to the right, we're actually going to have a negative exponent. So in this example, we only have 2 digits to worry about, so that decimal place will be in between, once we move it, the 5 and the 6. So 5.6 times 10 to the what exponent is what we're going to figure out. So we need to determine how many places we've actually moved that decimal pot. So we go 1, 2, 3, 4, 5. So because we've moved our decimal place to the right of our numbers, we will have a negative number. And so this should be your final answer. And again, if you were to put this into your calculator and press equal, you should get that number. So negative exponents indicate to us a small number. Okay, equals a small number. And positive exponents equals a large number. So if you could keep those in your head, those two concepts, positive exponents, large numbers, negative exponents, small numbers, that could help you navigate between your scientific putting your numbers into scientific notation.